Okay guys, now let's look at question 3 here, and we'll crack on and we've sort of achieved merit level questions, and then maybe do another video for the last excellence questions. Okay, so this simplify fully means that we're squaring 4, and so that's going to give us 16, and when we're taking a power of a power, we multiply those powers, so we've got x to the power of 6. Solving this equation, our first step of working is we'll add 2x to both sides, so that we've got all of our x's onto one side, and so we can write down 5x plus 6 equals 7. Okay, our next step of working is we'll subtract 6 from both sides. If we can get our pen to write quickly, so subtract 6 from both sides, so our 6's cancel out, and then we're left with 5x on one side and 1 on the other side. So our last step of working is to divide both sides by 5, and so our 5's cancel out, and all we're left with is x equals 1 over 5, and we can't simplify that any further. Okay, question C is a quadratic because we've got an x squared, so that means that we're going to have to subtract 6 from both sides, and so on this side our 6's eliminate, so we're left with 2x squared minus 6x minus 12 equals 0. Okay, so what we're going to do here is divide both sides by 2, and so 2x squared divided by 2 is x squared, and then negative 6x divided by 2 is negative 3x, and negative 12 divided by 2 is negative 6, and now this is a nice straightforward factorisation process. So two numbers that multiply to negative 6 but add to negative 3, well, let's see here, we could have we've got 6 and, whoops, oh, we've made a mistake here, haven't we? Let's take things back a bit. So it looks like I just threw in 6 there when actually that's supposed to be 5. Okay, so we'll have to factorise this differently. Okay, so we're going to have 2x at the start and x here, and numbers such that they multiply to be 12, but when we times them with 2x, we're going to end up having 5x at the end. So what if we have, well, let's just list the factors of 12, 6 and 2, 3 and 4, and just consider if we can multiply any of these by 2 to get a difference of 5. So if I multiply 4 by 2, that gives me 8, 8 minus 3, that gives me 5. So I'm going to have 4 here and 3 here. We need our biggest number to be negative, so we're going to go negative and plus. Okay, now that we have, we've lost our place here. Now that we have factor, so what do we got? Should have negative there, plus here. Now that we have factorised, we can say that either 2x plus 3 equals 0, or x minus 4 equals 0. So subtracting 3 from both sides, we can say that 2x equals negative 3, or x equals 4, and then dividing both sides by 2, x equals negative 3 over 2, or x equals 4. And so those are our two possible answers for this question. Alright, so on to a word problem now. And Sarah agrees to pay $7 a day and $1 per kilometre for each that she travels. Write an equation for the amount P that Sarah agrees to pay. So P is going to be equal to 7 times the number of days plus 1 times the number of kilometres. That's it. Okay, Sarah travels 185 kilometres and should pay her friend 213. Use your equation to find the number of days. Okay, so she pays her friend 213 and she is away for some number of days that we don't know, and she's travelled 185 kilometres. So we're going to solve this equation by subtracting 185 from both sides. And so we've got 7d equals 28, and just because divide both sides by 7, so d's cancel out, and d equals 4. So Sarah borrowed the car for 4 days. Okay, so I think we'll just keep moving on here because we're on a bit of a roll. Okay, Emma is 3 times as old as Tara. So what we'll do is we'll say that E is Emma's age. Emma's age in years. And we'll say that T is Tara's age in years. Okay, so Emma is 3 times as old as Tara. So that means that Emma is equal to Tara's age times 3. In another 7 years, Emma will be twice as old as Tara. So Emma's age plus 7 will be twice as much as Tara's age plus 7. Write at least one equation, use algebra to find Emma's age now. So we've already done that, we've written 2 equations in fact. And what I'm going to do is substitute this in here instead of E, and then we've got an equation just with t's in it. So then I've got 3t plus 7 equals, we'll expand our brackets here, 2t plus 14. So next step of working is we'll subtract 7 from both sides. So we've got 3t equals 2t plus 7. And we will subtract 2t from both sides. So they eliminate on that side, and we're left with 1t equals 7. So Tara's age now is 7, and Emma's age is 3 times that, so Emma's age is going to be 21. And so we'll write a sentence saying that. So Emma is currently 21 years old. And that's it. Okay, question F. Express x in terms of y. So all this question is asking us to do is write x equals and have it in some form of y. So we're going to start by taking the 4th root of both sides, and that leaves us just with x cubed equals the 4th root of y to the power of 2 to the power of 3, which is to the power of 6. And we'll just simplify that a little bit. And so that means y to the power of 6 to the power of a quarter. And so when we're taking powers of powers, we can times them. So that means that we've got y to the power of 6 over 4, which simplifies to 3 over 2. And now we'll take the cube root of both sides. So take the cube root of that side and the cube root of that side. And so that leaves us just with x. And on the other side, we've got y to the power of 3 over 2, and when you take the cube root, that's saying over the power of a third. And when we're timesing fractions, the denominator and numerator cancel out if they're the same number, and so that just leaves us with x equals y to the power of a half, which also is the same as the square root of y. And that's it. So that's question 3 all finished there. And if you can keep a cool head, you can see that it's pretty achievable. But obviously you'd have to work through the process a bit more when you do it yourself as well. But that's it.